Jai Hind students, welcome back to my Python tutorials, and today I'm going to discuss about one of the chapter of Python, chapter 6, recursion. Recursion is one of the process or a technique that we use to solve the problem in which a function call another function within itself. So it's a process or a technique that we use to write a program in Python where a function called the other function within itself is called recursion. This is what recursion is. Sometimes just to avoid the loop or iteration that we do with the help of looping concept in Python, we can use the recursion or we use the recursion. Now, a function calling another function inside its body is what the recursion is, and a function is called to be recursive if it is calling itself within its body, then it's called a recursive function. So for example, if a function, suppose any function you say, suppose you can say apple is a function and calling apple itself in its body. Now as you can see, this is the definition of the apple function, and in its body there is a calling of the same method apple. So this is what the recursive function is. If a function or function said to be a recursive function, if it is calling a same function within its body, in this situation as you can see apple is calling apple itself, that is what the recursive function is. Recursive function. Situation may be like this also. If A is calling B in its body, here A is a function, B is a body, or B is a function that you're calling, and you may have a B as a function and you are calling A inside it. Now in this scenario you can see, once body A is calling the B function, it will search the body of B. There is a definition of B where you are calling the A. It means A calling B, B calling A. Both function keep on again iterating or executing, and it's an infinite, as you can say, it's an infinite loop. Infinite iteration or looping will be there. Since once B will be called, it will jump to the body of B, there is a calling of A, so A will be called, again A is calling B. So this process will continue again, keep on executing, and there is no end of it. This is infinite condition or infinite execution of this. Now once the same function is calling its function name with its body, it's called direct recursion. Direct recursion. And if a function is calling another function and another function calling another function, this is the situation of indirect recursion. Indirect recursion. I hope what recursion is. Recursion is a process or a technique that we use in Python to write a program in which a function calls the other function in its body. That is what recursion is. A recursive function is a function which call its body within, which call the same function within its body is called recursive function. Here apple is a recursive function. A is calling B, here A is also recursive function. B calling A, here B is also recursive function. But this is a direct recursion, this is indirect recursion. These are the two different kind of recursions we have. Now in every recursion method, we are using this recursive function or recursion method to reduce the complexities of any programming technique where the too much calculation are required to some extent. That's why we are using recursion. Every recursive method must have these two case, base case and recursive case. Let's see what are the base case and recursive case in a recursive function. Now base case is basically a case that is a predetermined where direct value will return and function stop executing. That is called base case. And recursive case is again calling of recursive method till a particular again extent or so many times till the base case is not again achieved or till the function will not get the base case. So there are two situations, base case and recursive case in a recursive function. Let's have an example how to reverse a string. So reversing a string in Python by recursive method. So I am using here recursive method or function. Let's see, a function is there, its name is rs, reverse a string, and it will take an parameter as a string that will pass and the length of it that you have to pass. So I am defining a function which job or which task will be just to reverse a string that will pass as an parameter and the length of it. Now in this body, as you can see, there may be two situations. One, suppose if first, that is the base case we are talking, if the n equal to 0, it means the length is 0. Once length is 0, then as you can understand, since a string has only one character string. So same will be revert, there is no revert, that's why you can simply say return or say print, because we want to see that. So print and inside the bracket str of, and then you can say 0. Now here this is a base case because it's a finite. One situation may be there when the value of n equal to 0, and once the value of n equal to 0, it will simply print that character. This is one of the case in recursive method that should be there, and as a base case it is. Now you can say else, or you can say elif. Else means if this is not the case, it means value of n is greater than 0. Then in that case we have to say print, and then we are printing the str of n. If you want a space, then you just say int equal to space and bracket close. What I am trying to do, the call, then if this is not the case, then it will give me the print of str of n, depend on the whatever the value of str n is, and then call the method, that is your rs is a method here. Call the method with str, that is a string, and n minus 1. I am reducing the value of n. It means every situation, if the value of n is above than 0, the function will show me the last again characters of that string, and it will call 1 minus. It means it will show you the next character of the string, and it will show you next character of the string till the value of n will not reach 0. It will keep on again displaying the string character from the backward. Moment the n equal to 0 will be there, it will come to just simply show you the first character of the string, or itself the 0 character of the string. This is called recursive case. This is recursive case, and this is called base case. Now to understand the base case and recursive case in recursive function, try to understand it. In every program of recursive function, we must have one base case or more than one base case, where a predefined or predetermined case is there. We know that n will reach to the 0, and once n is a 0 only, then it will show me this. Otherwise it will keep on calling this function so far the n is not reaching to the n equal to 0. Let's see, if I am passing this method, I am calling this function, so str or s equal to, I just say Mohan is my string, and then I am calling the function. So you can simply say, simply call the, because both having this, you can say rs inside the bracket s comma and the len of s minus 1. Now after writing this, once I am passing this Mohan, what is happening? 0 1 2 3 4, that is 5 is the length of the Mohan. As you can see, the value of n is 4 in this case. Total it is a 5 land, and I'm again calling it till the -1, that is till 4, and it is 0 to 4. It will give me first, since I said if it is not that, since 4 or 5, whatever the length of the Mohan is, it not matching this case. So it is jumping to this. It will show me str of n. And what the str of n is here? 1 minus. It means str of 0, 4. 4 means n. So output will be n. Then again, it will go to the executing the same, because this is not true. N minus 1 means 4 minus 1, 3. Now third alphabet, that is A. So it will show me A and A. Then H, then O, and M is a last. After that, it will not execute. The reason is, once it is a M, the value will reach to the 0. And at 0, we are saying str of 0. So once base case will reach, during the execution of the recursive case, the program stop executing. And that is what base case and recursive case in recursive function. So what do you mean by base case and recursive case? In every recursive function, we must have one or more than one base case and then recursive case. Base case is a case that is known or predetermined in the program, where direct value will be returned and program stop executing if that case will occur in the program, and otherwise it will go to the recursive case. Recursive case will keep on executing the same function till it not again get the or reach to the base case. That is what the base case and recursive case in any recursive function. I hope by this program of reversing a string, you can understand the base case and recursive case. Now how recursion works, this is also clear by this program. This recursive function keep on again executing the RS function. This function will execute with the different value of n, because n is here 5, 0, 1, 2, 3, 4, 5. 5 is the length of Mohan, and I'm executing it because 5th will be the character. There is no character at the 5th position, so length I reduce to the 4th. So it will work first again with the length that is 0 to 4, that is the 5th character. So n will be the first. After that it will go to the 4th position, then 3rd, then 2, and then 1. Once it will be the 0, then it will stop. It means it will keep on executing this function till the value of n is not reaching to the 0, and that is till the string is not coming to the first character of this Mohan string. And that is how recursion works. I hope this program will help you to know what recursion is, how the base and recursive cases are in the recursive function, and indirect and direct also I told you what the indirect and direct again recursions are. Now let's see another example. If you want one more function, I am again talking here. Suppose you want to again find out the summation of first to nth term by the recursive method. Now function is sum, and one parameter I'll pass, that is n, that is the nth term, and first to nth term, that summation you want to find out. Mathematically you know n into n plus 1 by 2 will give you the summation of this, but how this program will be written by the recursive function that we are seeing here. Situation again, we have to find out the base case. So in this function, if n user has given 1, n equal to 1, then simply you say return 1. As you can see, the function having n as n parameter, that is nth term of the series whose summation you want to find out. And if the n itself is a 1, so 1, if a number is 1, means you want to find out the summation of only 1. That's why return 1. Otherwise, you can say else. Now, I have to call this function. Now, this function, if you want to else, what you can write here, I have to call the function now. So, your return, and then call the function sum. Now inside the bracket you are calling return, then the value itself, that is n, and then plus you are calling sum n minus 1. Why it is? Because n, if it is a 5, so it will be the summation will be 5 plus 4 plus 3 plus 2 plus 1. Here I am taking the n, that is if n is greater than 1, and in case of 5 it is greater than 1, so it will jump to this, and 5 plus, then I am calling the sum function. It is a recursive case again, recursive case, and this is base case. So it will give me 5 plus, then again I am going to call the function sum, and 5 minus 1, that is 4, that is sum of 4. Now since it's again n equal to 1 is not the case, since it is a 4, so it will jump again in this. So 5 plus, then 4 plus, then 3 plus, then 2 plus, then 1. And once it is a sum of 1, as you can see n equal to 1, that's why 1, so it will give you the 1. So total summation, that is 5 plus 4 plus 9 plus 3, 12 plus 2, 15 plus 1, 15. You will get the 15. This method, sum method with the n minus 1 value, keep on iterating, keep on executing till it is not reaching to the base case. And this is how the base case and recursive case are in Python. So with this program, I can end up, you can go to any program that you need or that you want. For example, you may take the Fibonacci series. Now let's see how to generate a Fibonacci series in Python by recursive method. And as you can see, fib is a method which having one parameter, and if the predetermined case or base case in this recursive function is if n equal to 1, it will return 0, because the first element of the Fibonacci series is 0, 1, 1, 2, 3, 5, and so. So this is the first again Fibonacci element of a Fibonacci series. So once n equal to 1, it should return 0. If it is 2, that is second term, that is a 1, it should return. Else it should return Fibo n minus 1 plus Fibo n minus 2. If it is this two cases is not there, suppose if it is a 0, 1, 2, 3. So if it is there, third user has entered second, that means this plus this. So this is minus 1, this is minus 2. This 2 will be added and 2 will be, so 0 plus 1, 1. That's why n minus 1 plus n minus 2 will be added and it will return. So to get the 0, 1, 1, third element you are getting, previous 2 added together then. And likewise, fourth element you are getting, previous and another previous, that is 2, 1 plus 1. Then next element is 3, 2 plus 1, 3. Then 3 plus 2, 5. What you are seeing here, basically the wherever the nth term is minus 1 and plus n minus 2. Previous 2, this is minus 1, this is minus 2, and will be added together to generate the third. That is how to generate the Fibonacci series in case of Python by the recursive method. And Fibonacci series is a series where we get the third element after adding the two consecutive element, the previous element. That's why 0, 1, 1, and 1 plus 1 previous, that is 2. 2 plus 1, that is third, next third, and 3 plus 2, there is a 5. This is how the Fibonacci series is there. In case of normal formula loop, you already know how to generate it. You can have two variables a and b, 0 and 1, and then you have to say a equal to b and b equal to a plus b. That is how you can generate the, or keep on saying the a will give you the this Fibonacci series. But nth term, to find out the nth term here, n is a term that will be accepted from the user, pass it as a parameter, and then call the two situations. This two situation of ours, this both situation is a base case, and this is a recursive case. I hope this is okay. How to generate the Fibonacci series and by the recursive method. Now just to have a binary search, as I mentioned, the binary search is a process to search a particular element in any array which are in order either ascending or descending. And how to search it, it's a very easy process. I have written a program here, as you can see. By the recursive method, if you want to do it, just have a method. And here I have taken B search, that is binary search, and there are 4 parameters I am passing. One is the array, that is a complete array or list where you want to search it, then key is an item that you want to search, low or high value, two values I am passing, where the low value is the initial value and high value is the again length minus 1. If the low is greater than high, if that is the case, then return this. This is exception cases and you will get this message. Otherwise, midterm will again find. Midterm is a low plus high divided by 2. And if key equal to AR of mid means item that you are searching is at the middle position, the middle position is the mid term of mine, then simply it will return mid. And otherwise, if the key, that is item, less than AR of mid, means the item that I am searching, that value is less than arrays of mid, then high value will be minus, then mid minus 1. Otherwise, return. We are calling this recursive function here B search. Here recursive again cases is there. This too is a determine one if key equal to AR of mid. This is one of the base case. We can take the example of the base case because we know this. And if this low is high, this is a different again situations. You come to this first. If key equal to AR of mid, then base case it is because directly returning it. If key less than AR of mid, it means value of the item that I am searching is the lesser than the middle term of the array, then high value will be mid minus 1. It means it will go reverse direction, middle left side it will search. And it will call the function B search with the AR key and low and high, else low equal to mid plus 1. The lowest value will increase, middle plus 1. It means our searching will take place wherever the middle term is, then onward. In the previous case, the searching will be in this direction, and now the middle direction onward. And again I am calling this function recursive case, it is AR comma key comma low comma high. Now once you have an array declared with the element in an order, then you just again calling this function. So to call this function B search, we have to pass the array name that you have declared list name, item that you are searching, and the low is simply low equal to 0 and high is length of array minus 1. These 4 parameters you have to pass, and then you have to call the since it's returning, so you have to accept it in a variable and check that value of that variable and print it. This is how the binary search is. Now comparison between the recursion and iteration is a very easy. Iteration and recursion both does the same task. By the iteration we are using a loop in Python to iterate the particular loop until so far it required it continue. And in case of recursion, you have seen a function keep on executing within its body till it is not getting the or reaching to a particular case, that is a base case. Now sometimes your iteration seems to be very easy, sometimes the recursion seems to be very easy. Recursion can be used at the place of iteration, iteration can be used at the place of recursion. That is what comparison is, that is what similarity is. Recursion process takes more memory utilization of your computer because every moment a recursive case occurs. It generally creates a fresh copy of the method in the memory, but in the case of every again execution of the for loop, iteration of the loop, it utilizes the same memory location wherever the previous again task has been performed. That's why recursive function or method takes more memory and your iteration takes less memory utilization. Otherwise, both are applicable for any circumstances. You can perform any program or do any program by the either repetition or iteration or by the help of recursion. Thank you all. Kindly go through this all again and let me know if there is a query, there is a difficulties either through the comments, video comments, or you can directly get in contact with me on WhatsApp. Next class, I'll see the next chapter, that is a 7th chapter of yours. And beforehand, I'll request you all completely finish all again so far whatever I covered in the Python, so that it will help you to get the next lesson of mine. Thank you all.